So in this session, I'm going to focus on assemblies in SolidWorks 2016. So we'll see how we are going to model and create assemblies using SolidWorks, right? So basically, assembly is a collection of parts or sub-assemblies. Basically, it's a collection of parts. The parts are created using the features, and the parts, a collection of two or more parts will create an assembly. Sub-assembly which is similar, uh, which has a subcategory of the assembly. Now, from parts you form sub-assemblies, and the collection of sub-assemblies is an assembly, right? So we'll create two parts, and then we will create an assembly. So I create first part. I'm going to create a bolt and a nut, and as well as a washer, right? So first I will create the first part, which is the bolt. So I will enable these three planes, and I will draw a sketch on this plane. Now I will create a hexagonal bolt. So I'll use hexagon tool. Number of size is 6. This is inscribed circle, and then I'm going to create from the center a hexagonal shaped bolt. So I'll just connect to here. No, I'm going to do this. We create a hexagon which will align with the x and y axis. So I create the hexagon shape, then I'm going to extrude this part. About 20 millimeters. Then on top of this surface, I'm going to create the bolt, right? So I'll create a bolt of 20 millimeter in diameter. Put a smart dimension. Which is a diameter of 25. Let's say it is 25, right? Okay, and we'll extrude this. So we'll just let's say this has a length of 60. And now we have created the bolt. I will not create the threads. I will just create the shape of the bolt, and then I will save this. Now it's a good practice if you save it in a all the parts in a same folder, one folder. So I'll create a new folder. Say it's 4MA 4MA009, and let's say bolt save. Then we create the nut for this bolt. So I'll close this bolt, create a new part, this part. So now I'll create a new sketch. This will be also a hexagonal nut, which will have a hole of 25 millimeters. Let's say this has a diameter of 25. We will extrude this say 15 millimeters. So now we have created the nut. Of course we can chamfer these edges, so let's just chamfer these edges also for aesthetic purposes. Draft. So we create a hexagonal nut, and we will create chamfers. Let's create, go to under the fillet you have chamfer. You put a small chamfer which has a dimension of, let's say, 4 millimeters and has a 45 degrees. So we'll use these edges to chamfer. That is a bit large, so we'll put a chamfer of 2 millimeters. That would be enough. So we'll chamfer all the edges. Let's click. So now we have created several chamfers, so it looks okay. Right. So now we have created this part. We'll save this same folder. This is nut. Now we will create a washer. So I will close this part and I will create a new washer. So part, we will enable these three planes, and then we will create a washer. So so the internal diameter is 25, and outside we will put a diameter of 38. We will go to features, extrude, thickness of 2 millimeters. So now we will place this as a washer. We will save this as a washer. Right. So now we will go to the assembly. So in order to create a new assembly, we have to create new, go to another separate file which is known as an assembly file. You will click on this and click OK. So now in order to begin the assembly, we can open the document and put all our drawing files, all our part files into the assembly. Right. So we'll browse. We'll select all these three parts, then select open. So we'll place these items. So now we have placed the items. Now we need to assemble. First we need to assemble this nut, the bolt with the washer on bottom of this bolt, and then we're going to fix the nut. So first we need to assemble them. So in order to assemble them, we can use, under the assembly tab, there's the option called mate option. So in the mate option, what you have to do is you can position the two components relative to one another. So that means you can put different constraints between these two parts in order to create a mate. That means by creating a mate, we are going to assemble these two parts, right? So basically, if you create a mate, you will have only two objects, either surfaces, solids, or edges, right? So now first we will see how we are going to assemble this. So now we'll select, first we will select mate. Now they will ask you the mate selections. What are the entities to mate, right? So now we need to first this bolt should go through the nut inner surface, right? Inner cylindrical surface should be aligned with this cylindrical surface. So for that we are going to use one of these standard mates. I'm going to use which is known as concentric mate. So concentric means you can align two circular faces align which has the same axis, right? So I use this concentric option to create the mate. So first I will select this surface, the circular surface, and then I will select the bolt's surface. Now it will automatically will align with the bolt with the nut. We finish this. Now you can see we have created the nut and the bolt at the circular surface. But here now, if you notice, this nut can be pulled. It is not fixed. It is not fixed. You can move the nut, right? Now, if you look closely in the design tree, there's something different. Okay. Now the bolt has a F symbol in front of this bolt, right? That means this bolt is fixed in the assembly space. But now you can see there is a minus value for the nut and minus value for the washer. That means these two objects, the nut and the washer, are not fixed and they are floating, right? They are floating. Now let's see how we are going to assemble the bolt and the washer. So we'll use the same method to the mate, concentric. We'll select this surface and then we'll select this surface. So now we have created a concentric mate. Okay, so this is also movable. Now we need to place this washer surface on top of the bolt surface. So in order to do that, we need another constraint mate, which is known as coincident. So we'll use coincident mate, right? Also coincident means basically you are going to uh, paste. We are going to paste this, right? So first we'll select first object as the bolt surface, and then the second surface is the washer surface. So now it is fully defined, right? So there is no movement in the washer. If you look closely, you can see I think you can rotate the inside, but you cannot move. It is fixed. Now we will do the same thing to the nut also. So nut will have a coincident surface between the washer and the nut. So we'll use coincident. Then we will select these two surfaces. Now we'll do another experiment. Now the bolt and the nut are firmly fixed with a washer in between the bolt and the nut, right? Now we'll do some identify some of these other standard mates, right? So I will put another new component. So I'll just close this. Now this is okay. We'll insert another component. So for that we are going to go into insert component, and then we can browse it. I will put a washer. Now what I want to do here is basically I am going to put a new mate which is known as tangent, right? Tangent means basically you are touching those two surfaces. They are not concentric, but they have a tangent connection, right? So I'll use this tangent option, then select this surface, and in the washer I will select this surface. So now both of these are tangent. That means they are not in the center, but they have a tangent mate. Now you can see the circle. You can move anywhere, but it has a tangent constraint, right? Right. Now you can see this washer has a tangent constraint. Now I have what I have given here is the edge. Now you can see I have given here what I have given here is the edge. Now let's see what happens if we put this surface. Okay, this surface. Right? We'll see how we are going to place that. So we'll just right click on this. Now first we'll go to the mates and we'll use this tangent. We edit this tangent mate, right? Say edit mate. Now instead of this edge, I'll remove this and then I will use this surface. Now it is tangent with this face as well as this face. Now let's see what will happen. Now this is tangent, right? So you can still move it all around, but now notice here, right? This will not flip. It will not flip, right? You cannot rotate the washer. It is firmly in a tangent mate with the bolt. It is not like when you specify an edge, right? Okay, so that is the basis of assemblies. So now I will show you some examples of mates. So I will just use I will show you an MCB box and let's see how I have placed the mates. Okay, this is an MCB box. Now you can see here. Now this is a transparent cover. It can be opened and closed, right? So let's see what I have given as mates. First I have given a coincident mate between the box and the top cover, right? This is the base, and with the base and the top cover I have given a coincident mate, right? The second mate I have given these surfaces, this surface with this one, right? So again base with the top cover, and I have given another coincident with the, let's take a cross section, see where we have placed that mate. Let's see where we have placed that mate. I have placed that mate between these two surfaces. This, now you can see there's a small ridge, right? That set will go through this ridge and then it will mate in these two surfaces. Okay, now I have given another concentric mate for the top cover and the top lid. Now if you look closely, right, I just remove this. Now if you look closely here, right, I will do another projection that way. Okay, like this. Okay. So now, if I go to the hinge where the top lead, this is the top lead which will connect to the top cover, right? I have placed. Now you can see between now in the top cover you have a circular edge, right? You have a circular surface or an edge, right? For this circular edge, I have placed the knob of the top lid, and I have put a concentric mate, right? Then I have put three other mates, which is the distance mate, angle limit, as well as a parallel mate, right? So let's see one by one. So distance means basically how you get a distance is, I'll just minimize this and I'll show it in the this thing, right? So now I will I will remove this tangent option. Yes, I will remove this. I will put a distance mate, right? So how to put a distance mate? You just select mate and see, should be under the advanced mates. Yes, under the advanced mates you have this. You can give a distance, right? So now if you specify this distance made, this is an advanced made, so I'll give between the surface and the nut surface, right? I'll give a distance of 1 millimeter. See here, but since I have not made it quite concentric, I will make this concentric to look. I will put a standard made which is concentric. So I will select this surface and then this surface, right? This concentric. Now I have placed a distance of 1 millimeter under the advanced mate. So you will just see the distance mate, right? We will edit this mate. I will put a larger value. Let's see what will happen, right? Here I have placed, let's say I have a distance of 6, right? Now here the distance, I have put the washer in the washer. Now, yes, under this distance, I have limited this distance between these two washer and the nut, right? So if you move this, you cannot move this because we have put a distance made. Okay. So you can use under the mates, the standard mates, and also you can use as advanced mates such as distance, right? And you can limit the angle also. Here you can limit the angle. Click here and then you can limit the angle, tilt angle, and the gap between these two tilt angles. You can do it very comfortably, right? Okay. So yeah, that is about assemblies, right? So you can see here the internal of the MCB box. See it clearly that some of the mates I have placed in order to create a functional body, right? Functional body, right? So this is a industrial MCB box, right? So you can close and open the lock, right? there's a small recess. Okay, this is small recess that you can put your finger and then lift up, right? Mm, so yeah, right. So we will stop for the moment, and the next week I will explain you how to create drawings. Okay, I'll explain to you how to create drawings. Okay, so we will conclude this lecture.